I hope that you're thugging it up worried about your grade. Okay, so what we're going to talk about today is how to use exponential functions in the real world. That's what we're doing. So we're applying this to where we actually use this outside of school. So first we're going to start with exponential growth. That's when something gets bigger, right? And usually it's with bank accounts and your house and how it appreciates and stuff like that. So on the first page where it says exponential growth, it says exponential growth occurs when a quantity increases by the same rate, which is represented by R, in each time period T. So this is the equation that we're going to use whenever we have an exponential growth. And we're going to be able to differentiate between growth and decay. That's our goal. Now, the Y, what we're going to do in this next part is we're going to break down what each of these parts mean. The Y is your final amount. That's what you're looking for. The A is your starting amount. What is R? What did it tell us our R was up there?
Percent.
That's your rate or percent. Good. And how do we write those? Do we write those as a decimal? Yes, you turn percents into decimals. So this is going to be a decimal. And what is T? Time. Who said that? Take a point. You're not funny. Then you shouldn't be laughing. Alright, so what we're going to do is we're going to take this problem right here and we're going to plug it into our equation. Now, you're going to use this equation every time, and you dissect the problem, you get what it's asking you, and we go from there. Are you ready? So this says the value of a Jackson Pollock painting. Do y'all know who Jackson Pollock is?
No.
He's a painter because it's a painting. He's an artist.
Wow.
Look at us go. All right. So it is currently worth $52,000. The value of the painting increases at a rate of 4.7% each year. How much will it be worth in the year 2035? So first what we need to do, we are going to plug in the information that we know. Now, do we know what Y is? We don't know what our final amount is, so we're just going to write Y equals. Do we know what our starting amount is, though?
Yes.
What is it? 52,000. So that's our A. Do you think that 1 is going to be there every time?
Yes.
It is 1 plus. Now, we have talked about percents before, my children. You move it 2 decimal places. So if it's 4.7, you're going to move it 2 to the left, and it's going to be 0.047. And how much time is going to pass between the year 2017 and the year 2035?
30.
No.
15 years.
Are you sure?
I don't know.
Well, why don't you do 2035 minus 2017 and tell me how many years are going to pass? It's a math class, Troy.
More than a year. Yes, 15.
2035 minus 2017. I'm so grateful that there are 3 people subtracting this. So you 3 people add a +1 by your name. Thank you so much.
I got 18.
You got 18? CJ, is that what you got too? Good. Don't sit there and lie.
I did!
Who are you hollering at?
Even him.
you know?
I don't trust Henry.
What?
Yeah, hold
You
on.
said he was your boy.
That did it.
You said he was your favorite.
There's
Said
a
it not.
cane on it.
Alright, so now what we're going to do,
I'm sorry, you ain't our favorite.
we're going to work this problem out. Are you guys ready? What is 1 plus 0? What is 1, blah, blah, blah. What is 1 plus 0.047? 1.047 to the 18th power. Now, is that 18th power, is it on the 1.047 or the 52,000? The 1.047.
You explained that one.
I added the numbers together. I did this right here. I just added them. That's it. No magic. Because we're going from the year 2017 to the year 2035. So we did 2035 minus, that's times, minus 2017, and that gave us 18 years. To show Bronson where we got it from. Okay, so now everybody should have a calculator because we have to use exponents. So in your calculator, I want you to type 1.047. 1.047. And then I want you to hit caret. Good. And I want you to hit 18. Caret is this button right here. It looks like a little rooftop.
Oh, that's like a green with something.
This button right here, that means x to whatever power. And so then type in 18. Okay. Alright, so once you have 2 point blah, 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 I want you to multiply that times 52,000. So hit times 52,000. Don't hit clear, just hit times 52,000. Now since it's money, what decimal place do we round to? The second decimal place. And we're done. That's it. That's all you do. Yeah. Okay, so let's walk through it one more time. So we did 1 plus 0.047, right? And we got 1.047. Then we do 1.047, and we hit this button right here to the 18th power. This button right here. It's called a caret. Looks like a rooftop. And you hit equals. And then you're going to multiply that times 52,000.
Did you do money for our first problem just with that?
No, that's what you use exponential growth on. Now, the sheet that I just passed out to everybody, what do I do with one? That looks like this. I want us to go through first and determine which one you think we're going to use growth on and which one you think is going to be a decay. So, number 1 says you buy a house for $130,000 and it appreciates. So does appreciate mean it go up or down? Up. So is that a growth? So let's write growth right here. That's going to be a homework problem. Number 2 says Mr. MD is losing 20% of his hair. So is that a growth or decay? Decay. Is that going to be a homework problem?
No.
No, because we haven't done decay. So write homework by number 1. Number 3, if you invest $40 in an account for 10 years at a 3% interest rate, how much money will you have? Is that a growth or decay? That's a growth. It's going to be a homework problem. A population of 100 frogs increases at an annual rate. How many frogs will there be? That's a growth. Bronson, what is happening over there?
Oh, I almost cussed you out. I swear to God, I almost cussed you out. I'll look that high.
Jarek, breathe.
Hey, stuff like that, bro. I was bitching. Like, I just said something.
That was literally.
Bro, and then he kept talking. I stopped talking.
That wasn't
Why did somebody else complain?
But why are y'all talking?
All I said was because he was on tonight. All I said, he was saying something.
Okay. Alright. A species of extremely rare deep water fish are slowly becoming extinct. If there are a total of 821 and there are 15% fewer fish each month, how many will there be? That's a decay. And that's a very sad decay.
Very morbid decay.
Dude, they don't have lights. Like they always just swim around. How's that sad?
Because it's a living being.
It's not a human. It said leave it.
So what if you
It's a living being.
Bro, what if your dog died?
And it's a creature that deserves our empathy. And D'Angelo.
Okay, but you
Stop.
can't say your human life doesn't matter. Huh?
Try in your life, how would you feel?
I'd be dead. I wouldn't have any feelings.
Okay, so the population of Austin is growing. Is that a growth or decay? Do you think that growth problem is going to be a homework problem?
No.
No, this is. No.
Alright, number 8. A mouse population is decreasing. Is that a growth or decay?
Decay.
Decay. Hello, coach.
What is this is a transversal, right?
Yes. So then you take 8x plus 21. That plus sign should be right here, and that equal sign should be right there. So you add those two together because that whole angle and that whole angle are congruent.
Is this not the transversal right here?
Yeah, but they can both act. This transversal right here that you drew with the black line is intersected by this one. So this part of the angle is 16, and then this whole thing is 8x plus 21. So you would add those together to get that top one.
You know, I have one of those on the
No.
Okay.
Oh no, the testing is like, if they got today and they were fine, they're gonna like
Well,
the
they're
test is
getting
gonna be a
through.
cakewalk.
They're getting through G.
Yes, and that's pretty much what it is. Alright, so a super deadly strain of bacteria is causing the zombie population to double. That's a growth.
Why did we skip that?
It'll be a decay if they were asking about humans.
Because 7 says use the previous question and predict in what year Austin's population. So you're going to have to play with it a little bit on that one. Now, let's talk about, we're going to skip number 10 for now. Let's go back to number 1. Did you say something? Oh, I'm sorry. I thought you did. No. So this tells you that we're buying a house for $130,000 and it appreciates 6% each year. So what's our initial amount? $130,000. All right, and what's our growth rate? What's the percent?
6%.
And how do we turn that into a decimal?
You go to 2 decimal points.
So that would be 0.06, right? Okay, so the function that represents this, you're going to plug it into our thing right here. So you're going to say y equals a times 1 plus r quantity to the t. And then you're going to plug all of this information in over here and show me your work. If you need to work it out on a separate piece of paper, work it out on a separate piece of paper. So who can tell me what we plug in for A? 130,000. What are we going to plug in for R? What's our rate? 0.06. And what's our time? After how many years did it tell us this was going to happen? 10 years. Awesome. Okay, so now we just add it together. What's 1 plus 0.06? And now is when our handy-dandy calculator comes into play. So you're going to plug it into your calculator. You're going to do 1.06 and then the caret button. And you're going to raise it to what power? the 10th power. And then what are you going to multiply that decimal by? 130,000. Pardon? And that gives you $232,810.20. That's how much your house has increased in value.
A year.
No. So tonight, work out the ones that we wrote down were homework. Bring them back tomorrow. We're going to do decay.
You know,